All right, scholars, in this video, we're going to really just solve a right triangle. What does it mean to solve a right triangle? Well, it means to find all the side lengths and angle measurements. To do that, we need to combine everything that we've learned: Pythagorean theorem, trig ratios, and inverse trig functions. Let's dive into it. There is one other thing that we need to talk about, but we're going to cover it right away in this example. We need to solve this right triangle. What does it mean? Well, we have a right triangle right here. We have a few measurements missing. We have the measurement for RS. We don't know what length this is. We also don't know what QR is, so we need to find that. And we don't know the angle measurement for angle R. So we need to do that for everything. Actually, we're going to skip these two and go directly into the measurement of angle R. How we're going to do that? It's a small little thing called the interior angle sum of triangles. This is a little property of triangles that you've seen before in geometry that we really haven't talked about. If we take all the angles of the interior angles of a triangle and sum them together, it's going to equal 180. So if we took angle R plus angle S plus angle Q, all these angles right here, and we added them up, it's going to equal 180. We know a few things. We know that the measurement of angle S is 67 degrees. We know that angle Q, this right here, is a 90-degree angle. It's a right angle. That is the reason why it makes a right triangle. So this is 90 degrees. The one that we don't know is angle R. So how can we figure it out? Well, we just need to combine these and minus it from 180. That's all we need to do. So I'm going to grab my calculator, clear it. There we go, clear it. I'm actually going to move it over here. There we go. So a lot of things I'm going to do. I'm going to minus 67 from both sides, as well as 90. And this is going to help me find the angle R. So I need to take 180 minus 67 minus the 90. Boom. I figure out that angle R is actually 23 degrees. So right away, I know this is 23 degrees. So here, 23 degrees. It's a small thing, something that you've seen in geometry that will be helpful. There's other ways of finding that angle, but this is the quickest way. So interior angle sum of triangles. If we add up all three interior angles of a triangle, it equals 180. There we go. Now let's find the first one, RS. To do that, let's label our triangle because we're going to have to apply trig ratios. We don't have enough information to use Pythagorean theorem because Pythagorean theorem requires us to have at least two sides. So AB, then we can find C, or BC, and then we can find A, or if we know A and C, we can find B. But we need to know two sides. Unfortunately, we only know one. We're looking for two sides. We're given an angle right here and right here. Well, actually, we're given this one. We found this one. So we're given an angle and a side. So we're going to use this right here. Again, are there any angles shown? Yes. So we apply trig ratios. What are we looking for? Not an angle, but a missing side. So we're going to use trig ratio. So let's apply our trig ratios. To do that, we need to label our triangle. Here's my 90 degrees. Here is my hypotenuse. Now, I have two angles. I can choose which one I will use. I would err on the side of caution and go with the one that they give you. So I'm going to use 67. I could use 23, but for our purposes, I'm going to use 67. What side is opposite? Boop, this side. That would be RQ. So this is opposite. And this is adjacent. We don't need there we go. This is adjacent. Okay. Now, if I'm looking for RS, I'm going to then have to use opposite and adjacent, because adjacent is what is given to me. I'm going to use 67 as my angle. So, which trig ratio deals with opposite and adjacent? Tan. So I'm going to use tan. So tangent of angle 67 is equal to my opposite, RS, over 3, my adjacent. Oh, sorry. Wanted my calculator. There it is. I'm going to go to math, numeric solver. I'm going to put tangent 67. I just want to remind you guys, make sure you're in the correct mode. I am in the correct mode. I can see degree on the top, so we're good. On the bottom, I'm going to do my fraction. I'm going to put x for RS, 3, go down, put a 1 in there, because I don't want to make any crazy mistakes. I want to make sure my guess is positive. Press alpha, enter, and there we go. I get RS to be approximately, I need to round to the nearest tenth, so it's going to be 7.1. So here's 7.1. So I figured out RS. Now I need to find QR. Looking at my triangle again, I have 67 as my angle. I'm given the adjacent, and I'm looking for my hypotenuse. This is QR. So I need to deal with a trig ratio that deals with adjacent and hypotenuse. Well, that is cosine. So I'm going to kind of divide this, and I'm going to say cosine of angle 67 is equal to, let's see, it will be 3 over QR, my hypotenuse. And there we go. Grab my calculator, do the same thing, come up here, change it to cosine 67. I'm going to put a 3 on top this time, and I'm going to have an x. And this is where I need to make sure I put a 1. If I put a 0, I'm going to have an error. And there we go. I get QR to be 7.7 when I round it. So 7.7, there we go, which means my hypotenuse is 7.7. And that gives me a good point of relief, because my hypotenuse should be the longest side, and my hypotenuse is 7.7, which is longer than the other two sides. So there we go. So there's a lot of things that we're combining. In this case, we're using interior angle sum of triangles, and we're also using trig ratios. Okay, there's two types of problems. So this problem, it's the first one we talked about. We're going to talk about the other one, but I really want you to think about what we're looking for. Here we're looking for two sides and an angle. Okay, the next example is going to be us looking for one side and two angles. Okay, so here they give us two sides but no angles, right? We're trying to figure out what those are, as long as, and also one side. So this is the other type of problem they're going to give us. Okay, first we need to find, well, I mean, we can actually find anything. There's really nothing that would be easy for us in the beginning. So let's just go down the line. Let's find HI. Okay, here, let's look at the diagram. What are we doing? Are we looking for any angles, or are we dealing with any angles? No. So we're going to go down this route, which means we got to look at Pythagorean theorem. Pythagorean theorem, perfect. We're given two sides, right? And we need two sides to find the third one, right? So we're going to use Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. I need to label my triangle. The side that is most important is my c. That is my hypotenuse. So right here is my hypotenuse. So I'm going to label this hypotenuse. It is my c in my a squared plus b squared equals c squared. So there we go. I'm going to just label the other two sides as a or b. Doesn't really matter. I'm just going to do that. A in my case is 7, so I got to square it. My b is a 5, so I got to square it. And my C is what I'm looking for. So I can apply a numeric solver to help me get there. So I have 7 squared plus 5 squared. And I'll make this x squared. Press OK or go down. Press 1 as my guess. And there we go. I'm going to round to the nearest tenth. So that means C is approximately 8.6. So I already know that HI is 8.6. Again, this is HI. So this is 8.6. I'm going to do it in red. 8.6. There we go. Now that I found my third side, I'm now going to look for the angles. First angle that I'm going to look for is angle I. So here we are. This is my angle that I'm going to be looking at. If we look at our diagram, finally, I am, are there any angles shown? Yes, I'm looking for angle I. So I say yes. Let's apply trig ratios. What am I looking for? Am I looking for a missing side or missing angle? I'm finding missing angle. So I don't go down this route. I'm going to apply inverse trig ratios. Perfect. Let's apply them. I know all 3 sides, but I'm going to utilize the sides that they give me, just so I don't compound on the error, because I remember I approximated 8.6. They gave me 5 and 7 to be exact. So I'm going to utilize 7 and 5 over using 8, okay? Just so I don't compound my error. To do that, I need to first figure out what is 7 and 5. Is it opposite or hypotenuse? Opposite or adjacent. That's going to depend again on I. This is my theta in my case. So let's figure out the opposite side. Boom. Opposite side. Opposite for 7. And that makes adjacent side for 5. Let's do that. I'm given side 7 and side 5. I did find 8, but again, I don't want to use that. I don't want to compound my error. So which trig function deals with opposite and adjacent? That'd be tan. But I want to use the inverse. So let's use the inverse of tan. So angle I is equal to the inverse of tan inverse of tan, which has opposite on top, 7, and then 5 for the adjacent on the bottom. I don't need numeric solver for this. I need to press second tan, grab my fraction, and do 7 over 5. Close that parenthesis, press enter, and what I get approximately is 54.5 degrees. So I have 54.5 degrees. Okay, there's 2 options you could do. You could apply inverse trig again to find h, or you can utilize the interior angle sum of a triangle. So we're going to use that to find it. So again, if we look right here, angle H plus angle I plus angle G. When we add all 3 angles of a triangle, or interior angle of a triangle, it equals 180. I'm looking for angle H, so I'm going to keep that. I know angle I just found it as roughly 54.5, plus angle G, which is the 90. Again, this is the 90. They should all equal 180 degrees. I'm going to minus the 54 from both sides, as well as the 90. So I'm going to minus the 90 as well. And when I do that, I will find angle H, and I'll figure out what that is equal to. So I take 180 minus the 54, and then minus the 90, and I will figure out what that is. 35.5. So my angle is 35.5. And there we go. I have figured out all the measurements for this triangle, so I have solved it. Again, you are going to utilize all three of these, depending on the situation, to solve these right triangles. You will also have to use this interior angle sum of triangles, which equals 180, to find some missing angles. If you guys feel confident, try your skills with GPR. If not, raise your hand and we'll come by and we'll clarify. Otherwise, guys, I'll see you in the next video. Utilize this flowchart. It is very helpful, very meaningful. If there's no angle showing or you don't care about angles, use Pythagorean theorem. You do need at least two sides to find the third one. If you are given angles or you're looking for angles, then go down the trig ratio. Either find missing side or find missing angle. If you guys, again, have any questions, reach out. Otherwise, have a great day, guys, and I'll see you in the next one.